Thank you everyone for attending my talk. So today we are going to share some experience and lessons we have learned when we build our data pipeline inside Databricks. So here is a little bit about who are we. So my name is Yupen, and my colleague Barak, we are working in data science team at Databricks. So basically we are working on building our data pipeline inside Databricks. So every company has its data pipeline. We know that building a data pipeline is a hard problem. So there are a couple of reasons why it's hard. So usually a classic data pipeline, you need to provide at least once, or sometimes exactly once semantics. And then you want to make your data pipeline fault tolerance because the service could fail and the job may fail. You need to make sure it can recover automatically. And then resource management is also very important. So you want to make sure your job have enough resources to finish the job in time. And also, you don't want to waste the resources on these jobs. And then the scalability and maintainability are also very important to the data pipeline. So what is our solution? So what is our solution inside Databricks? So of course, the answer is not surprise. We use Apache Spark and the Databricks itself. So that is our solution. So what does it mean? So first, all our ETL jobs are built on top of Apache Spark. So everything is inside the same place. So it's very easy to maintain. It's very easy to change. And then you can do unit test, integration test very easily. And then second, all the ETL jobs we have are run inside Databricks platform. So as you may already know, Databricks is a platform built for data science and also data engineers. So you can launch a Spark cluster very easily and run your job. And then you can use this cluster to do your interactive data analysis inside the notebook we provide. And as a side effect of building everything inside Spark and Databricks, we actually test Spark and Databricks new features with our data pipeline. And then we can fix the bugs. We can get quick feedbacks and then fix things before delivering the actual features to our customer. So okay, let's take a look at what a classic Lambda data pipeline looks like. So basically you have a lot of service, and then every service generates some logs. And then you want to collect all this log and then send to a centralized messaging system. So from this centralized messaging system, you have some data, you have some job that doing the real-time processing, and then write your final result to some storage system. So this system could be HFS or S3 or some kind of database. And then you also have some batch ETL job that runs some expensive processing and then finalize the table and then generate the output, and people can use that thing. So how do we do that inside Databricks? So we are doing very similar thing. So basically, we have a lot of different customer deployment. And then every customer deployment generates a lot of logs. And then we use Amazon Kinesis as our centralized messaging system. So many people ask why Kinesis, why not Kafka? So here we have two main reasons for using Kinesis. First is the security, because we are building our system based on AWS. So using Kinesis make it very easy to integrate with the other part of the system. So we just need to change an IAM role and the permission, then we can just send data to Kinesis. And the other thing is for the maintainers. So because we are still a small company, we don't want to maintain our own Kafka cluster. So we just use Kinesis and it just works. Okay, so let's take a closer look at our customer deployment. So inside our customer deployment, we have many Databricks services. And then also, we maintain many customer clusters. And inside every cluster, we have some other services. So all these services are generating logs. So we have our log collector called Log-daemon that is running inside every EC2 instance we create from Amazon, then send the data to Kinesis. So after we have all the data inside Kinesis, the next thing we do is we actually send back the data to our Databricks deployment. So Databricks deployment is just a customer deployment inside our account. So there is nothing special to this deployment. It's just a customer. So which means that if we can do all this data processing inside our deployment, our customer also can do that inside their deployment. So inside Databricks deployment, there are two features we are using, the two main features we are using for our data pipeline. First, we have the Databricks file system. That is based on S3. So basically, it's a wrapper of S3. And then we have some nice feature. For example, we have multipoint, we have access control. So this makes us very easy to interact with S3. And possibly in the future, we may integrate some other file system. And then we use Databricks jobs. So this Databricks jobs means that if a job is triggered inside Databricks, Databricks will automatically create a Spark cluster for you. It go to Amazon and ask for some instance, and then create the Spark container, and then set up all the configuration. Then you can run your job. And then after the job finish, it will clean up all the resources and terminate the instance, and then all the resources is free. So okay, so let's take a look at what is actually the job we run inside Databricks jobs. So first, we have our real-time analysis jobs. So basically, we are running Spark streaming jobs that read from Kinesis, and then do some processing, and then show some dashboard insights. Then our internal customer can look at this dashboard. And then after, then we have some other job that doing the actual ETL thing. So we have a service called Daemon that read from Kinesis, and then we cache the data, write a raw record to Databricks file system in batch. So with this service, we just need to handle the files inside Databricks file system. And after that, we have our ETL job that do the actual processing, and then convert the file format, and then finally we save some Parquet tables inside our Databricks file system, so that our end user can look at this Parquet files and then do the data analysis on top of that. So one thing to remember is all these things are happening inside Databricks deployment. Okay, so that is basically what we are doing in Databricks. And then I will talk about every component separately. So first is the log collection. So log collector we build in-house. So the reason we build this by ourselves is because there are some special requirements for our use case. First, we want to make sure it's fault tolerance, because the service itself could fail at any time. And then our log collector could also fail at any time. The thing we make sure here is if Log-daemon is up and running, it will go back to the history and check and resend any message that was not sent before. And then, of course, this log collector can work in a streaming manner. And we have a special use case that we want to support a simple file upload to our Databricks file system, because we are maintaining our Spark history server for those cluster already terminate cluster. And then because the cluster is already terminated, it doesn't keep the logs. So we need to have some place to store the logs, and then we can get from there. And then the last requirement is we want to make multi-tenant and config-driven. So you don't need to change the source code when you just want to add some new services to the log collection. And because we are maintaining the dynamic Spark cluster, so we are frequently add or remove container to the cluster. So this is actually help a lot for our management and log collection. So this is the architecture of our Log-daemon. So you can see we have a long-running service called Log-daemon here. And then inside Log-daemon, we create one log string for every service. And then we persist the files, or we persist the states inside in files, so that when the Log-daemon is up, it will go back to check all the active log and the rotated log files, and then send any remaining messages. One thing to know is we actually only keep one instance of our messenger producer, because messenger producer could be quite expensive, especially for Kinesis producer. And then we do some aggregation inside the messenger producer, and finally we send data to Kinesis. So after we have data inside Kinesis, we run our Daemon as a service, as a long-running service inside Databricks jobs. So it's also a Spark job. And it does very simple thing. It just read from Kinesis and do some caching and do a very simple partition by day and write data to Databricks file system. And that's all. And then after that, we have our ETL jobs. So basically, there are two kinds of ETL jobs. One is the Delta update. So basically, it gets all the recent file that added to the file system. And then we do the processing. And then we just append to the final packet tables. And then after one day close, we actually have another daily batch job that read all the data for the previous day. And then we do a very expensive dedupe to make sure we have exact ones schematics. And finally, we override a table partition for previous day. And then after this job, the data is finalized, and our end user can start using that table. So there are a few good things about the ETL jobs we have. So basically, with our model, we actually use the same source code for the Delta job and the batch job. So you just change. So you just need to say what is the input files, and then all the other things are the same. So it's very easy to test. So we think this is a very good feature because I know that some people use different pipeline to do the real-time thing and the batch thing. Then the code sometimes is not consistent. And then we run all this thing as scheduled Databricks jobs, as I mentioned before. So you don't need to worry how to allocate the resources. It does everything for you. And it also do the automatic retry if the first run fail or this kind of thing. And then the other good feature we provide is, so we know that for AWS EC2 instance, Spark instance is much cheaper than on-demand instances. So what we do here is if you ask AWS for Spark instance first. So if we can get that, if we use that instance. If you cannot get enough instance from Spark instance, then it will do a fallback to on-demand. You create that cluster for you. And finally, we deliver all these tables as Parquet tables inside Databricks. So you can see actually this is part of our Databricks UI. You can see those tables, and then you can see the table schema, and then you can run your SQL query on top of this table, and then do your stuff. So okay, then I will hand over the stage to my colleague Brock. He will talk about the lessons we have learned and how do we actually use this data pipeline inside Databricks.
Great, thank you, Yu. That was a great intro. So while I want to talk about what you talked about, our ETL pipeline, I just want to talk about how we use Spark. And like when we use Spark, we hit issues as well. But we learn a lot of lessons from it. We fix it. We continuously improve it. So I want to talk about some of the lessons that we learned. One of them was basically this is not our first pipeline. This is not our second data pipeline. This is basically our third or fourth data pipeline since Databricks started. And what we noticed was that we needed to learn from our mistakes, what we did before, how to make it more scalable, how to make it more maintainable, and how to address more use cases asked for our engineers. So what we did was we basically laid out the use cases of we get the data in, what are we going to do? And then once we fleshed those requirements out, we noticed that we run some specific queries, and these queries we run them over and over again. And basically, they usually involve several columns of the whole table. So basically, what we noticed was if we can filter on these predicates as partitioning columns, we can basically save a lot of time, we can save a lot of compute resources, and we can save a lot of money. So basically, we used partition pruning since Spark 1.5, and then we noticed that for some of our queries, our query time reduced from 2,800 seconds, which is 45 minutes, to just 15 seconds. Now imagine this improvement. This means that I don't need to use as big a cluster anymore. This means that I get access to the question that I asked much quicker. So basically, we noticed that this partition pruning can help a lot of queries, and it could help you as well. But one thing to be careful there is that, so don't partition by too many levels. So here, Databricks uses S3 as a backing storage system. We noticed that if you have a lot of partition directories, it leads to a higher metadata discovery cost. So you need to know which columns are actually columns that you partition on. Therefore, you need to read all this metadata, and once you cache it, all the queries that you run later is much faster. But if you have too many partition levels, and basically if you use S3 and you think of a key value store as a file system, which it's not, it leads to horrible performance. So basically, the tip there, don't partition by too many levels, but look at which queries that you run most. Like partitioning by date is usually something that people do. And then basically you can optimize your performances. So one other lesson we learned during our pipeline was that we suddenly looked at our AWS bill and we noticed that we have a lot of S3 costs. And the reason of this cost was not storage, it was actually list requests. And we're like, what's going on here? And that kind of fits into the partition discovery that I mentioned before. Metadata discovery on S3 is expensive. And this metadata discovery you see happens even after you do Parquet writes. So basically, Spark C, as you can see from this graph here, this was like the count of list requests that we had over time. And we generated this graph using Spark, looking at CloudTrail logs, of course. There was like a pattern we saw that fit our Delta job schedule. And basically, we looked at why this was happening, and we noticed, hey, we're refreshing the cache, which we don't need to. So what we did instead was that if we have a constant column that we know, so if we're running, for example, partitioning by date, and we run this Delta job for today, we know the date, so you can run one level inside the table as like your base path. And this way, you will only have to refresh that sub-levels amount of data, which totally reduces your list requests and improves performance. Another thing we noticed was that while using Parquet, we noticed that the job would finish, and then the Spark UI would show nothing. The driver is running something, but we don't know what's going on. And we noticed that it was basically Parquet trying to write a summary metadata file. And when you're appending to a table that's growing larger and larger and larger, it's trying to recreate this summary metadata file from what's already there. And this leads to your job hanging, and there are no Spark tasks running in the end. It's just running on the driver. And it takes forever, basically, hours. Just trying to write like a 60 gigabyte summary metadata file, which is huge. So there's an easy way to turn it off. There's a Parquet config, summary metadata. You set it to false, and then you get over this issue. All right. So next, I just want to talk about how we run it all in Databricks. After Netflix's talk, I noticed our pipelines are very similar. But when they had the list of tools they used, there were 9 different images, 9 different tools. Well, we basically use just Spark and Databricks. The way Databricks empowers us to do this is basically by this jobs feature. So what we do is we basically prototype using notebooks. We write our code, and then once we're done with once we're happy with the code, we go back to our IDEs, we write unit tests, we write integration tests. And then once we have a library, we can use the notebook and library interface to call these functions to run our pipeline. And basically what we do is once we pass unit tests, we can, using the REST APIs, deploy our libraries to dev and staging environments, run it in jobs using the REST APIs, see that it succeeds, and once it succeeds, we have the confidence to actually run it in production, which we also do by just through the REST API. Also, one other feature here is that the clusters you can reuse existing clusters if you like, but for ETL, we don't want to do that. We want the ETL jobs to really work. So you can see here that we've actually used almost a terabyte sized cluster to ETL our logs, and we can fall back to on-demand instances in case spot prices are high. And you can also see that I can select Spark versions there. I can set a schedule And then once I set the schedule, I can set alerts. In case anything goes wrong, I get an email about it. I can set a timeout if like something's taking forever, this is unexpected, I don't want to waste resources, so I can set the timeout. And in case like something goes wrong, there are retries that you can do. And these retries usually fix how the job runs. And also you can see like the history of the runs that we have. And we use also the REST API again to see how long the jobs took. And if suddenly there's a spike in how long it took, this usually means like there may be something wrong and we investigate. Otherwise, we just set this up and we forget about it. And then it just runs. And as you can see, we can select all kinds of Spark versions. And this basically allows us to test out new Spark versions, fall back to old ones if we encounter a bug, or go to the newer versions for all the optimizations that we have. All right, so data analysis and tools. We got the data in, the ETL is done. What do we do with it next? So like I said, based on these use cases, that's how we designed our ETL pipeline. So what we wanted to do was basically debug issues. We wanted to monitor our services. We wanted to do some usage analysis, of course, to get insights into our customers. And we also wanted to test our product design and like do some A/B tests. So basically, for the first case was debugging. You know, we're all not perfect. Bugs go into production environments, no matter how much QA you do. So basically, once this bug happens, you need to figure out why it happened and where else did it happen. So to build these, we use our Databricks dashboards, and we have data widgets, basically, that allow our engineers to just enter like a customer name, the logs, the service that they want to get the logs from. And depending on when the incident happened, they can add a start time and an end time so that like we only give that portion of the logs. And since we know converting to UTC from San Francisco is hard, you can also select the time zone so that like you don't have to go back. Is it 7 hours now, 8 hours now? So that helps. And then once you run this dashboard, you get a tar file of the logs. If it runs on multiple instances, you'll get the logs for the multiple instances. And then you can debug your issues very easily. So once we noticed that we were like debugging a lot, we wanted to get ahead of the problems. So we set up some monitoring dashboards. So the graph you see here right now, it's basically the count of logs that we had, grouped by the hour and day. And also, we have the log levels. And you can see that like during the 26th of May at 1 a.m. UTC, which is, I believe, 25 minus 7, 18, 6 o'clock when we did our push, we introduced a bug. And basically, we used our monitoring systems to figure out this bug, notice this bug immediately. And then in 2 hours, we pushed the fix, and the issue was gone. So using Spark in a streaming manner, in a batch manner, and using dashboards gives us great visibility into all the issues that can happen with customer deployments or any other services. So for usage analysis and product design, basically for like offline analysis, we use Spark R, and we love ggplot in the data science team. So basically using Spark R and ggplot is a match made in heaven for us. To develop these graphs, basically the data frame API in R allows us to do like window functions, all kinds of grouping. I can even like just run a simple SQL command inside R and then get the data set from it, reduce my data into a like graphable amount, and then collect it in the driver, use ggplot to basically plot whatever I have. And I wanted to share you an interesting story we had about product design and A/B testing. So you all may have seen this morning that we GA'd Community Edition. basically, we did some A/B testing for the front page, homepage of Community Edition once we launched it for beta, closed beta in Spark Summit East. So we had our designers design, and we had a design from some of the higher-ups that thought, like their design would be nicer. And we noticed that the designer's design had 3 times more active users in the Community Edition. So that basically, the takeaway message is trust your designers. All right, so a quick summary. For us, Databricks and Apache Spark create a unified platform for ETL, for data warehousing, for data analysis, and for real-time analytics. And the biggest thing for me is that like issues with DevOps is out of the question. I don't have to worry about managing huge clusters. I don't have to worry about managing a 3,000 node yarn cluster. Jobs are isolated, so like if multiple jobs are running at the same time and you can't schedule it because the resources are already in use, I don't have to worry about any of those. And I can also launch any Spark version when I want it. And it's not up to the IT department to like wait 3 months and launch Spark 1.6, install it, and then basically I use scikit-learn. They need to install a new scikit-learn. I don't have to worry about that, basically. So a quick recap on the ongoing and future work. So structured streaming is super exciting for us. We want to use it to reduce the complexity of our pipeline. You mentioned that we have the sync daemon, delta, and batch jobs, which cause some complexity, cause some latency. And we want to combine all of those into a single streaming job. Basically handle everything just with structured streaming, and it's what it's great at. Exact one semantics, end-to-end. We also want to use structured streaming to reduce the latency. So the way that the sync daemon, delta, and batch jobs work, the availability of data is now in minutes. But that's not good for monitoring cases. We want the data available in seconds. And structured streaming, just being a single job, will make that availability, the latency, very short. And since the support for event time has entered the fray, we want to use event time dashboards to better understand our use cases and usage analysis of customers. So before letting you all off, try Apache Spark with Databricks at databricks.com. Try for free, Community Edition. I hope you all love it. All right, thank you. If you have questions about ETL with Spark, we'll be at the Databricks booth from 3:45 to 6 p.m.
And we have time for, I think, 1 question right now. So if anyone has a question. Oh, there we go.
Since talking about deduplication, and you mentioned that you do that at the batch level, not at the delta level, and said something about this is an expensive process.
Yeah.
So wouldn't it be cheaper at the delta level? Why are you waiting?
I mean, so it's basically because of the way the Log-daemon works. If late data comes in, late data can always come in, or like a failure happened. Yeah. So we can get it in a second batch. Therefore, like a day later or something, if a service fail happens. Therefore, we need to dedupe it at the end. Once it's coming out of Kinesis? Yeah, that's what structured streaming, that's what structured streaming is going to do. That's what structured streaming is going to do. All right.
Awesome. Let's give him one more big hand. Thank you, Barak and you.